Welcome back. So now jumping into our first concept whereby we're going to be looking at the cell as a chemical system. To begin, we need to know that electric cells and batteries are source of energy. So the electric cells and batteries, they are a source of energy and they are used to power electrical appliances. So the appliances that we use on our daily basis, the light bulbs, the radios, the remotes when you're controlling our TVs, our cell phones that is always in our hands, those are used or those are powered by the electrical cells and also the batteries. So, an electric cell consists of two terminals. Now remember, we have the positive terminal and the negative terminal. Now in this case, in terms of electric cells as a chemical system, we're not going to be looking at the positive terminal and the negative terminal. We're going to be looking at the electrodes. So those electrodes, they are made of different elements, which are usually the metals, and a conducting fluid or a conducting paste, which is known as an electrolyte. So by definition, an electrolyte is a solution that is used to conduct electricity. So as we can see on this picture that we have here, the solution that we are finding in these two beakers, it is called the electrolyte. So the zinc sulfate solution that we have and the copper sulfate solution that we have, those are referred to as your electrolyte. Now this solution is used to conduct electricity. So as we are saying that an electric cell consists of two terminals, which are the electrodes, and then those two electrodes are made of different elements, which are usually metals. And they also consist of a conducting fluid or a paste, which is known as an electrolyte, through which the charges can move once the cell has been connected to the circuit. So now, on this picture that I have the two beakers, which are known as half cells, and on these two beakers, we have these two metal rods, this metal rod and this metal rod. So those are going to be our terminals. However, we are referring to them as our electrode. So we have a zinc electrode and a copper electrode. Remember, we are saying that those two electrodes are usually made of metals. So the zinc is a metal, as we know, and copper is also another metal that we know. Then those two metals are dipped into a solution that is used to conduct electricity, and that solution is called your electrolyte. Now, these two, the solution being an electrolyte is different from the other one. So the solution, if we were to label this as beaker 1 and beaker number 2, the solution in beaker number 1 is different from the solution in beaker number 2 because of the electrode that is dipped into it. If we are looking at this picture, we are seeing that there is a zinc electrode that is dipped into the solution, and the solution is that of zinc sulfate. So there is always the relationship between the solution and the electrode that is dipped into. When looking on beaker number 2, we have our metal being copper, and our solution is going to be copper sulfate. So as we can see, there's a relationship between the solution and the electrode that it is dipped into. You will never find a situation where you have a copper and the solution will be a zinc sulfate. There must always be a relationship between the solution and the metal that is dipped into. So in other words, the solution must always contain the metal that makes up an electrode that it is dipped into. Now with that said, continuing with the electric cells, the moment a conducting wire connects the electrode, remember the electrodes, as we've said, they are metals. We used an example of a zinc electrode and a copper electrode. So now the moment a conducting wire connects the electrode, so now connecting the two electrodes with a metal wire, so the moment they are connected to each other, a chemical reaction is going to take place. So now I have my two electrodes on the two electrolytes. The moment now I start connecting the two electrodes with a metal wire, a chemical reaction is going to take place. Then the one electrode will act as a positive electrode, and the other one will act as a negative electrode. Remember, we said we are not referring to the electrodes as your negative terminal and a positive terminal. We are referring to them as your positive electrode and your negative electrode. And remember, those are usually made of metals. And those metals must always be dipped into a solution that is going to conduct the electricity. And remember, that solution is called an electrolyte. So, the circuit is completed by the movement of charges, which are sometimes referred to as ions, through the electrolyte. So those charges are going to be moving through the electrolyte, as we have said that this is the solution that is used to conduct the electricity. And the movement of the electrons through the external circuit. So the charges are going to be moving through the electrolyte, and those electrons are going to be moving through the external circuit from one electrode through the wire to the other electrode. So an electric cell is thus a system in which certain chemical reactions cause the flow of electricity by means of an external circuit. So what we are saying that the electrons are going to be moving from one electrode passing through the wire to the other electrode. So now that means one electrode is going to be losing the electrons and the other one is going to be gaining the electrons that are lost by the first electrode. So now with that, we are then saying that one of the two electrodes will be more negative and the other electrode is going to be more positive, because remember, at the beginning of the reaction, there's an equal number of protons and the equal number of electrons on each electrode. So once one electrode loses electrons to the other electrode, then the electrode that has lost electrons will be more positive, and the one that is going to gain the electrons is going to be more negative. And because of that, there's then going to be that flow of charges through, or the flow of charges through the electrolyte, and those electrons are going to be moving from one electrode through the wire, through the external circuit to the other electrode. So before now we go to the next concept, which still is referring to the electrical cells, we are going to quickly go for a short break, and I will see you just after this.